Hello everyone, my name is Fluin, and I'm really excited to be here today to talk about Angular performance best practices. This is a topic that I spend a lot of time working with teams on, and it's one of the top things that we hear are concerning developers as they continue to build out Angular applications. And so the goal today is really to help you understand how to think about performance and how we think about performance, and give you some concrete tools that will help you manage and make your application faster. So before I get too into things, I want to introduce myself. So as I said, I'm Fluin, and I am a DevRel lead on the Angular team at Google. Now, I have one of the coolest jobs in the world because I get to spend all of my time talking to developers, building cool apps, solving problems. But there's really two parts to my mission. The first part is to help developers and organizations be successful with Angular. And the second part is to understand what it's like being a developer who uses Angular and listening to the community so that we can reflect those needs onto the Angular team. And so this is why I have so much love and passion for this community, because we have so many amazing people in it, and I get to help listen and be a part of their journey with Angular as well. I really think it's helpful to understand Angular by looking at some of the things that the Angular team values. And so we generally talk about three different values. The first is apps that users love to use. No matter who you are out there, you are building an application for a user. I don't care if you're building some backend RPC that is doing some ETL data loading. You are ultimately doing that to serve a user in some way. And it's really important to acknowledge who those users are and what they're trying to get out of the systems that we're building. I also think the Angular team values apps that developers love to build. Angular is successful because we spend a lot of time thinking about developer experience, and we try and have empathy for what it's like being a developer in the world. If you flash all the way back to 2009, around the first time that AngularJS was being created, the question in the team's mind was about this idea of, if we could build an API, if we could build applications the way that felt naturally and made sense to us, what would that actually feel like? If we could ignore the browser for a second and just be declarative about the things we want to be rendered and how we want them to be rendered, what would that look and feel like? And we carry that through today, where we think a lot about what does it feel like to be an Angular developer, where can we be opinionated, where should we be more flexible, and how do we continue to push this experience forward so that we continue to grow with the ecosystem. The last value we like to talk about is a community where everyone feels welcome. And this is really critical to us because there are thousands of teams out there. There are thousands of libraries, authors, developers, tooling, creators, or vendors that are all out there building with Angular, building on top of Angular. And we want a community where everyone feels welcome, where anyone can feel like they can walk in and receive value and contribute back to that ecosystem. We spend a lot of time trying to support that in terms of presenting at meetups like this, in terms of listening and trying to be a part of the community. So we are always trying to do better, and we are always trying to listen. So please keep feedback coming. We really appreciate it. So this talk is all about performance, and I always like to talk about why performance matters, because I think it really sets up the concept of performance really, really well. So performance matters, going back to that first point when we talked about user values, where apps that users love to use. If you are not building a performant application, your users are going to be frustrated, right? We talk a lot about things like mobile experiences. Mobile experiences for most users in most applications end up being the primary use case. The number in the US is something like above 70% of web usage is actually coming from mobile devices. And in places like China, that number can be over 90%. And so when you are thinking about building an application, thinking about the context that your user brings with them is going to make your application more successful. And so you have to really think about performance. Now, in Angular, there's a couple types of performance we can think about. There's build performance, there is startup performance, there's runtime performance. Generally, what we see is that when we think about users, runtime performance in Angular is very, very good. It is pretty easy to create fast, responsive applications where you're preloading data and you're giving users instantaneous experiences. But startup experience is actually something that's a little bit harder. You can't just throw more JavaScript at that problem, because when we look at the performance of web applications, bundle size is the number one factor when it comes to startup time and bootstrapping time. And so there's a couple really interesting metrics to look at when it comes to understanding performance in web applications. And so there's actually a group within Chrome that have come up with this concept of web vitals. And so these are three metrics that I think are the most meaningful in terms of representing a user's actual experience with your application. So the first one is what we call largest contentful paint. Largest contentful paint is if you think about all the times that the JavaScript or HTML is rendering and painting to the browser, what is the largest paint? Because that largest paint is probably going to be the one that has the most meaningful content for your users. And so understanding how long it takes to get to that largest contentful paint is a really strong signal about when the user is actually getting the most meaningful content of the application. The second is something called cumulative layout shift. And so if you remember metrics like page speed, this is a little bit like that, but looking at the amount of layout shift that has to happen in order to render a page. And generally you want to minimize this, right? If we have applications that render one way and then they change and they render another way, and then they change and they render another way. Maybe that's because of images are loading and pushing down the page. Maybe that's HTTP requests going and fetching data and displaying it to the screen. All of these things can be disruptive to the user experience. So minimizing this layout shift is one of the goals, one of the ways to measure user experience. And the last web vital is called first input delay. And so this is a measurement of after an application is loaded, or when a user first performs an action on the site, like clicking a link or trying to interact with a form, how long does it take for the application to respond to that first input? And so the combination of these three metrics is actually very powerful. And this is something that really is being pushed on by the Chrome team as the measurement of whether or not you're building a great application. So the first two are very toolable. You can build them in a lab. You can actually check every PR and see what is the largest contentful paint, how long does it take, and how much cumulative layout shift is there. But the last one, first input delay, you can't actually automate because you can only observe it in real developers and in real applications, because first input delay necessarily depends on a user clicking on something or performing some sort of action. And so that can't happen in a lab because you don't know when the user would finish reading the page or finish understanding what the page is asking them to do and actually asking them to interact with the page. And so these are kind of really three interesting metrics where all of the things I'm going to talk about are going to improve the metrics that you see here. When we talk about startup performance, because this really, we do see this as one of the most important categories that affects those web vitals, the number one factor, as I said, is bundle size. And so when you are paying attention to your application's performance, you should really be paying attention to bundle size. So what we're looking at here is an actual screenshot of a source map tree. And so what this is a breakdown of all of the code that's being run by the browser. And it actually attributes it back to the source of where that code came from. And so we're going to talk a lot about this, but effectively, if you want to care about performance, you should care about startup performance. If you want to care about startup performance, you should care about bundle size. So let's kind of dive in. So as I said, bundle size is the number one factor in startup performance. And a lot of people think this is just network based, but it's not just network. We see a lot of times that this is also CPU bound. So things like parse time, where if you have a low-end device, you might have a 4G or 5G internet connection and you can load files really quickly. But if you can't parse those giant files fast enough because these phones have limited CPU, your startup performance is still going to suffer. And one of the biggest problems that we have that's endemic across our ecosystem is that oftentimes we as developers, we are using desktop machines, we are using fast internet connections, we are using powerful machines, and we don't see these problems while developing. And so you have to develop this culture and this mentality of recognizing and acknowledging these things so you can make them better. There are two things that I'd recommend everyone go and do in basically every project that you do with Angular. And this is going to be in the angular.json file. So right at the root of your application in your angular.json file, which configures your Angular application, I recommend you take a look at two different keys. The first key is source map, and the second key is named chunks. And I would say set those both to true. So what the first key does is it allows you to actually automatically generate source maps whenever you do a production build. This will allow you to do the sort of source map analysis that we're going to talk about. And named chunks is a really helpful thing because if you're doing lazy loading, which is a best practice we're going to get into, your application is actually going to split up into a bunch of different pieces. Maybe you have one chunk for your admin interface, one chunk for your editor interface. And if you just rely on the kind of default build, all of those chunks are going to have just random arbitrary names. But I find that it's not really a security problem. It's not really an obfuscation problem if you just give them the names that comes from the file system. And so this is a really helpful thing for looking at source maps, for debugging. It's just helpful across a number of different metrics. I talked about how so much traffic comes from mobile devices in the US, and I can't underemphasize this because it's a disconnect where if anytime you're doing development and you're not in the little developer preview mode and you're not slowing down your internet connection, you're going to be building a worse application than you think you are. So another feature that's really important in Angular for understanding and measuring startup performance is bundle budgets. The Chrome team has done a ton of work working with websites to try and improve their performance, right? Trying to follow best practices, trying to make the apps faster. And they were almost always successful at that. But then what they ended up seeing was that after a few months, teams would backslide because teams are looking to build new features. We're trying to pull in new libraries, new dependencies, and build cool things. And that process naturally starts to bloat bundles. And if you don't think about these and you don't force it to be a conscious decision, you're going to backslide and you're going to make the wrong choices in your application. And so within Angular, we actually have this thing called bundle budgets, where you can set budgets, both a warning level and an error level, on a few different bundle sizes. And by doing this and setting it to near the application bundle size of your app, you can control that and make it a conscious choice of, hey, I needed to pull in this new dependency. I'm shipping this new feature on my homepage. I'm okay with the bundle size increasing and changing. And another tip that I want to give is really stay up to date. One of the things that the Angular team does is, because we have this really opinionated stack about how we build, about how we code split, all those sorts of things, we can do things under the hood that make your bundles smaller over time. We did this in version 4, we did this in version 5, 6, 7, and so every time you stay up to date with the latest version of Angular, you're going to notice improvements to things like your bundle size without changing any of your code, right? We're going to make these changes and improvements to Angular and the build system configuration. They're going to make your apps better. And so if you're not on the latest version, you do not have all the benefits of the work that the Angular team is working so hard to give you when it comes to things like startup performance. So there are some dark sides to this, and I want to tell a funny story about a company that I was working with where they had a 15 megabyte bundle, and this was their JavaScript bundle. This was their first load, and we're like, how are you loading 15 megabytes? And so we started digging in to their code, and we did a source map explorer, because they had never done that before. We showed them how to create source maps, and then we ran source map explorer on that bundle size, and we saw that there was this huge chunk of code coming from a few of their components. And we started looking into those components, and we're like, what is this 15 megabytes? What we found out was that they were embedding SVGs in CSS scoped to components. Now, you may not know this, but when you scope CSS to a component, we actually then apply that CSS as JavaScript, right? We in the JavaScript layer are applying those styles to individual elements so that we can do things, and we're attaching that style sheet so that we can scope it, so we can isolate that component from the rest of the DOM. And so all of that CSS ends up becoming JavaScript. And so they were using SVGs in CSS in JavaScript. And so there was actually like 3 parse times necessary for the browser to actually execute this, where it would have to parse the JavaScript and execute it, then have to parse it as CSS and execute it, and then there's the SVG layer as well. And so just by getting in and doing a source map analysis, just by getting in and analyzing the bundle and understanding what was actually there, it was relatively easy for them to pull out those SVGs, have them as flat files on the disk that could be cached, that were far more performant, and their bundle size dropped dramatically, right? They instantly saved the majority of their bundle size, and their application dropped from being noticeably slow down to being a standard application that met their users' experience expectations. So we really do recommend that people be very, very important about what you export. This is something that a lot of developers run into without even knowing about it. So historically, we had things like RxJS, where if you imported it just in the wrong way, even if you were using the tool in the right way, but it did the wrong import, you could accidentally pull in features of RxJS that you weren't using. We made a bunch of changes with the RxJS team around version 6 to try and prevent these things, but there's a lot of cases where this still happens. So one of them is Angular Material and the themes. So Angular Material comes with some amazing themes that help you build really good looking applications, but you may not know this, but if you use the default theme, it actually is going to come with all of the different Angular Material components being themed. And if you're only using 1 or 2 of those components, you probably don't need the themes for all the other components that you're not using. And so think about the themes that you're using. Think about, hey, do we need to roll our own custom version of this? We have some documentation on this on the Angular Material website. We also see this happens a lot with third-party SDKs. So let's say you're pulling in Lodash, or Moment is one that I see a lot, where people will pull in Moment 1 or 2 times in their application, and they'll end up with 6 or 7 copies of the locales. And so just be careful in the way that you're importing, and make sure that the value you're getting from these libraries and from these dependencies is correspondent with the bundle size and the startup time and the performance cost that you're making your users pay. The final case that I want to do a little bit of shaming on is that we see a lot of marketing JavaScript where maybe people are trying to track their users, they're trying to have all these A/B analyses, they're trying to do like, I don't know, Hotjar, like seeing where my user clicked, see where they scrolled. All of those things are really valuable, but they can hurt the user experience. I've seen a live support pop-up that was trying to help people find what they need, but that live support pop-up was like 3 megabytes. And so it was just blowing their bundle size and their mobile experience out of the water. So what I want to do right now is I want to actually dive in and do a bundle size demo where we're going to take an application that I've got here. We're going to add some things in the AngularJS, just like we talked about. We're going to generate a source map, and then we're going to take a look at it, and then we're going to improve the budget based on what we're seeing. So let's dive over to the console here. What I've done is I've just created a brand new Angular scaffolded CLI created project. So this should look super familiar to everyone. So you can see source, we've got app modules, app components, and just like we talked about, we're going to jump directly into the Angular JSON file, and I'm going to search for source map. And I'm going to say that this is true, and I'm going to say that named chunks is true. So we'll just modify both of these to true. And now when I go back here and I run an ng build -- prod, what's going to happen is those keys are going to affect the build of my application. And we should get both source maps out instead of just getting out this minified JavaScript. And then we'll also get named chunks. We don't have any lazy loaded chunks, so we won't be taking advantage of that quite yet. But what this will do is it will set me up for doing the types of analysis that I want to do. One of the questions we get about source maps is whether it's okay to do source maps in production bundles. And I would say yes. If you are super worried about obfuscating your code, then you can consider not doing this, or you can just remove them after you ship to production. But in general, I don't think most JavaScript developers are relying on the security of their JavaScript. And the browser does not load the source maps unless the user is trying to access the source code. And so this isn't really a major problem, but it is a huge benefit because if developers are looking at source maps, they're going to make their application better. All right, so we've run our ng build -- prod here. And if we go into our dist folder, what we should see is we now have these JavaScript files from our application, and we should also see these map files. And so we recommend a tool for bundle size analysis called Source Map Explorer. There's a bunch of others out there like Webpack Bundle Analyzer. One of the things we've seen is that tools like Webpack Bundle Analyzer can actually miscategorize and misattribute some of the source code because it's applied at an earlier stage before some of the optimizations happen. Whereas Source Map Explorer is going to correctly attribute most of your JavaScript. So what I'm going to do is I'm going to say yarn add source map explorer. So we'll just add it into our package here as a dependency. And then I'm going to run Source Map Explorer and hand it the JavaScript file I want to analyze. So let's say we want to run Source Map Explorer, and we're going to run it on our main JS file. So what that should do is that should open a browser and directly pop me into the browser here where we have the complete bundle size of that file, and it's attributed down to here's the part of Angular core. Here's, for example, my application is using the router, and so that pulls in an extra 62 kilobytes of JavaScript. We've got some kind of basic operators that Angular is using and relying on, and then we can see things like my source code. So here's the actual source code for my app component. Here's the source code for my HTML, and if you pull in a library, all of that code will show up. If you're pulling in material, that will show up. So this is a really, really healthy way to understand, hey, I don't actually need the router. I don't actually need forms, for example, on my homepage. Let's make sure that we are not pulling that code into our bundle size. And so we can see that our application is about 216. So let's actually say, hey, we want to lock this down and say this is big enough for us, and let's actually start warning. And so here's, for example, the default budgets that we give you. We warn at 2 megabytes, but what we could do is we could change that to something like 200 KB. And then maybe we'll error if we ever get above 700 KB. So again, set these values as conservatively as possible. You can always change them later. You can always increase them. But if developers don't know what they're doing to the bundle size, they're going to make bad decisions. And so in the background here, we will run another build. And what we should see is when that build completes, these bundle sizes are going to be applied. So there's actually a few. So you can see we've got an initial bundle size. So that's what code is necessary to run the application startup. And then we've got any component style. So this is trying to make sure that you don't accidentally include a ton of styles into a single component. One of the places that we end up seeing that is if you use a CSS framework where you accidentally import the CSS framework into every component, and then we have a full copy of the CSS framework duplicated for every single component. So that's an anti-pattern, and this will help prevent that for you. All right, so we can see we've done our build here. Warning in budgets, exceed maximum budget for initial. So we've got a warning here, which is exactly what we wanted to see. So we've built an application, we've set some configurations so we can actually understand what's going on, and then we've set a budget so that we can prevent ourselves from making mistakes. So I'm going to jump back to the presentation here, and we will proceed. One of the things that you need to do to build great performance is really think about architecting for scale. And the key technology here is lazy loading. And in Angular, how this works is that your module layout is generally going to determine your lazy chunks, because lazy loading within Angular is really based on the router. And so what you should be seeing when you do a build, a production build, or a dev build, is you should see a bunch of different chunks, because whenever a user has an individual context where they don't need all the features of the other context, you should have a chunk for that. And so this is an example application I have where there's something like 14 chunks. Some of these are just polyfills and styles, but a lot of these are based on the features that a user is actually relying on for a given experience, for a given URL. Within Angular, it's really, really easy to use lazy loading. So there's a couple ways. So this is how you do it manually in the router. So if you say router module for root, instead of passing in a component, you can pass in load children. And what load children does is it uses dynamic imports that are a web native kind of capability now. It's supported by Webpack. And it will dynamically and lazily import that. And Webpack knows how to cut that code out and pull it into a different chunk, as well as all of its dependencies. And then once we've resolved that component and we've resolved that module, we're going to pass that back to the router, and then the router is going to intelligently load that. So this is the key piece here, where you load children and then you pass in that dynamic import. There's a lot of different thoughts and mentalities around lazy loading. And so first place I always go is lazy load your admin routes. Admin routes tend to have a lot of features that developers don't need on their homepage, right? There are things like editor interfaces. So if you ever have to collect forms, you have to fill out a wizard, think about lazy loading those, because again, you don't need those on your homepage. But you can even lazy load your homepage. This sounds a little bit weird because it's still in the critical path, but by pulling it back into another chunk, you're actually yielding back to the browser an extra time, which can make the application feel more responsive, and it can give the browser a chance to intelligently optimize things. So even lazy load your initial route of your application. And at this point, you should really be thinking about lazy loading everything. Right? You do not have to load any modules of your application except the application module asynchronously, right? Everything else can be lazy loaded, and then you can pull in all the dependencies at the right time. There's also a really easy way to do this with the CLI. So if you use the ng-generate command, you can say, generate me a new module, and you refer to the app module or whatever module is going to be linking into this. And then you can actually give it a route parameter and give that route a name, and then give it a name. And what will happen is it will create that module. So that first command here will create an about module, but it'll also create an about component, configure the router for receiving routing lazily, and it will configure the application module to lazy load that module when the user visits that route. And so this is a really, really powerful command that I definitely recommend you do a lot. So generate module, point to the module, point to the route, and then create it, and everything will kind of be done for you. It'll be set up for lazy loading, and that's a really, really fast way to move quickly to scaffolding out a lazy loaded application. There's another concept that you can be thinking about, which is that you should be minimizing the amount of code run, because what often happens, and some of this isn't fixable, but some of it is, which is we will ship down, let's look at this example, 700 kilobytes of JavaScript to the browser. But in terms of actually using the application, I'm only ever using 45% of that. And that's really missing an opportunity to optimize and pull some of that code out. And so this is one of the ways you can look at and understand, okay, maybe I'm not optimizing things as much as I could be because the code's not even running. It's not even running necessarily on the browser to execute the experience that I'm trying to deliver. So this is a really cool tool. It exists in DevTools. You just look at the bottom segment of DevTools and you click on those three dots, and then you click on coverage, and you can get out these reports, and you can see not only how much JavaScript you're using, but how much CSS you're using. So you can see I'm using like 96% of my CSS in that one file that we're looking at, which is a good sign that I don't have a bunch of unused styles that maybe I should be deleting in the first place, right? Maybe it's code cruft that I don't need to keep in the application. Another topic that is a little bit harder for web developers is that it's not just about building the best application anymore. We have to have a little bit of knowledge about DevOps and about JavaScript serving in order to build really good applications. And so I want to point out a few things about how to serve your JavaScript that will help the performance of your application greatly. The first and foremost one that I like to point out is content compression. So browsers support this for as long as JavaScript can remember, where the serving application that's sending down the HTML, sending down the JavaScript, sending down all these things can do compression. So you can use gzip, you can use Brotli. A lot of these things are built in. And what will happen is that it will take a module that is something like 900 kilobytes on disk and turn it into a 240 kilobyte network load. And that saving over half of your bundle size is really, really typical. Saving 75% of your bundle size is really, really happens very often. And some developers don't know about this, and some developers don't realize that they're not taking advantage of this. And so if you're using a CDN, it is probably configured to automatically do this, but take a look. So open up the DevTools, look at the network tab, and see what size is being sent down. And if you expand the rows, you can actually see the size over network, and then you can see the size on disk and compare those and make sure that you're taking advantage of content compression. I do a bunch of analysis of sites out on the internet, and I still see that more than 10% of sites are not taking advantage of this for their JavaScript. And so those sites that aren't taking advantage of that, their sites take 4 times longer to load in terms of network time. And so that is crazy that one tiny little configuration change can have such a big impact. The second thing I recommend people take a look at is HTTP 2. HTTP 1 was really good, lasted for a long time, making kind of the foundation underpinnings of the internet, but it created a new TCP connection for every request. So when it requested your index page, when it requested your JavaScript files, when it requested your CSS, each one of those was a new TCP request, which had all of the normal overhead of a TCP connection to a web server. Whereas HTTP 2 only uses a single TCP connection, and then it pipelines all of the different files that it requests over that same connection, which saves on overhead, networking, DNS, all these sorts of things. And so HTTP 2, you can see it in the protocol column here. So you can see H2. There's more kind of newer protocols that are coming out. And so definitely keep your eyes open for those, because anytime you can just rely on the transport layer to make things better for your application, make things better for your user, we should definitely be doing that. And once you have HTTP 2, there's a really cool set of features that you can take advantage of called server push. So server push allows you to actually let the browser and the server work together. It's important to understand a couple concepts here. So throughput is how much you can send in a given time frame. So like, let's say you had an hour, how much of bundle could you push down? Maybe you could push down 100 gigabytes. And then there's a concept of latency, which is that 100 gigabytes, maybe I can transfer it in a second, but if it takes a minute or if it takes 10 seconds to generate before that transfer can even start, that's going to be a problem. And so without server push, we load the index.html, we parse that index.html, we then start loading the main.js because we see that it's required in a reference from the index.html, and then that main.js, maybe that's referring to another dependency or another chunk. And what ends up happening is there's extra round trips here. So if you have a high latency internet connection, it doesn't matter how fast it is, you now multiply that latency and that round trip time per little group here in the vertical columns. And so with server push, that actually can all be eliminated, because what happens is you can configure your server so that when a user requests the index.html file, you know exactly what files they're going to need next, right? You wrote the index.html file, you know they're going to load your JavaScript and your CSS and all those sorts of things. And so you can say, whenever your user requests index.html, start pushing down all these other files. And so you can eliminate those round trips completely. And if you're using something like Firebase, this can be pretty easy to set up. You can just set up some headers in your hosting configuration and say, when someone requests index.html, load main.js, load that is a script, load all these other JavaScript. And so this can be a really, really helpful thing to do. There's also this concept of differential serving and loading. Now, if you are on a recent version of Angular, this should happen all automatically for you. But the key idea here is that we want to support lots of browsers, but we shouldn't be sending our IE9 polyfills down to our Firefox users. And in modern JavaScript and in modern web, you usually shouldn't even be sending ES5 at all. So we have better JavaScript, we have more expressive JavaScript, and we can do a little bit better. So differential loading now as of version 10 uses your browser list. So just specify the browsers you need to support, and we'll automatically figure out, do you need differential loading? Can we send down ES5, or can we just send down modern JavaScript and ignore ES5 entirely in the build? So if you want to configure this, take a look at your browser list RC file. There is also Angular Universal. So Angular Universal allows you to pre-render your application either at request time in response to a user request, or pre-render it at build time, so that when you make changes to your application, you can pre-build it to static HTML and then just push that static HTML up to a web host. And this is really good because it can improve the perceived load time of your application, as well as make your application more machine crawlable by bots and parsers that can't actually execute JavaScript. Really consider SSR. Last year, almost no one was doing SSR, but this year, from the applications that I see, and I see a lot of applications, it's more than 25% of apps. And there's really great technology. So in version 9 of Angular, we shipped Angular Universal with pre-render support now, and there's a lot of cool innovations happening in this space. So if you take a look at Scully, for example, Scully allows you to really intelligently and in a content-aware way do these really advanced pre-rendering strategies and take advantage of things like the Jamstack, which is really exciting. So universal today, if you do take advantage of it, it can increase the time to interactive or the some of these metrics from the Web Vitals, because what ends up happening is it still has to bootstrap your application, but it also has to parse and paint the HTML that you send it. So you're kind of increasing the work for the browser, even though a user might have a better experience. There's also some problems where, for example, you can't, or we actually swap out the client-side bootstrapped version of the application for the pre-rendered version. So we just remove all the DOM and add new DOM back. And so if you use advertisements or things like that, that can create double impressions. So you should think about that. And generally, nothing is interactive until everything is, right? It is not a progressively loaded application. But there's a lot of options that you have as a developer. You can think about the user experience you're trying to build. So you can cache generated pages, you can take advantage of pre-rendering, or you could do something like only serve universal versions of an application to a machine, to something that doesn't know how to parse and run JavaScript. So let's just end up quickly talking a little bit about the future. In Angular, we really do see more lazy loading coming down the pipeline. Dynamic imports are a really powerful feature, and we would love things like being able to take advantage of component level lazy loading. So you don't need to load an entire module, you can just load a single component at a time. We also see things like module federation being very exciting, where imagine if we could independently build two parts of our application and know that they were going to keep working together. So this is one of the features that's really exciting. It looks like it's going to be coming with Webpack 5, and we're paying a lot of attention to how we could possibly take advantage of that. And I want to end up talking just a little bit about have fun. So oftentimes we get very, very obsessed with performance, which is a good thing for our users. But even if you have an application that's a few megabytes, you're probably in good company. There's probably a lot of teams that have similar applications. Not saying we shouldn't try and do better, but also give yourself a little bit of a break and make sure that you're trying to focus on the best thing you can do to build a great experience. If you want to build new features and your users are demanding more features and not performance, maybe go do that and consider performance and just budget what you have now so it doesn't get worse. But really make sure you're focusing on the user, because at the end of the day, we're here for our users. We're trying to make them successful, and that's why you should be caring about performance. Thank you so much for the time, and I think there's a Q&A, but if not, you can find me on Twitter, or you can always let me know what you thought of my talk at the survey link. Thank you so much. Bye.